The popular image of high intelligence is a person who speaks quickly, answers confidently, and demonstrates knowledge at every available opportunity. Cognitive research has spent decades documenting a different picture. People with exceptionally high intelligence tend to express it through behavioral patterns that are quiet, often invisible, and frequently misread as something else entirely, as shyness, as indecisiveness, as eccentricity, as social disconnection. The gap between what intelligence looks like from outside and what it looks like from inside is one of the most consistent findings in the field. Intelligence is not about what a person knows, it is about how the brain processes reality. And that processing manifests not in performances but in patterns, most of which happen where nobody is watching. The first pattern is time spent alone. Not as isolation, not as avoidance, as operational preference. The prefrontal cortex, the region responsible for planning, reflection, complex analysis, and deep processing, requires low-interference environments to function at full capacity. When social signals are constant, conversations layering, emotions radiating, social expectations running, the prefrontal cortex is pulled into managing the social environment rather than doing the analytical work it was built for. Research from the London School of Economics, published by Kanazawa and Li in 2016, found that people with higher intelligence report lower life satisfaction from frequent social interaction compared to the general population. Their brains allocate resources differently. Where most people draw energy from socializing, the high intelligence brain draws energy from silence and internal dialogue. This does not mean they avoid people. They are selective. One substantive conversation carries more value to their system than 10 surface-level exchanges. The second pattern is a curiosity that never reaches a floor. Not the kind that scrolls through a news feed, the kind that dismantles systems. Why do people behave this way in that specific context? Why does this process work by this principle and not another? Why does coffee taste different in two places that use the same beans? The brain automatically searches for patterns, hidden mechanisms, connections between things that appear unrelated. Neuroscientists link this to the default mode network, the system that continues processing even at rest, building associations between information gathered throughout the day. For the high-intelligence brain, curiosity is not a hobby. It is a background process that never terminates. This is why such people often become polymaths, drawn to physics and cooking, to Roman history, and watch mechanics. The brain is perpetually hungry, and the hunger does not diminish with consumption, it expands. The third pattern tends to be misread from the outside. Self-directed speech, talking to oneself. When a person verbalizes their thoughts aloud, they engage both the speech production and analytical processing centers simultaneously. Research in cognitive psychology, tracing back to Vygotsky's work on egocentric speech and confirmed by Lupien and Swingley in 2012, demonstrates that self-directed speech improves focus, strengthens working memory, and helps the brain structure complex information. The person is using language as a tool for thinking, not only for communication. Many scientists, inventors, and entrepreneurs have described this as a regular practice, not from loneliness, but because it makes the processing faster and more precise. The fourth pattern appears paradoxical. People with very high intelligence say "I do not know" without hesitation. This is not performed modesty. It is an accurate perception of the boundaries of their own knowledge. The Dunning-Kruger effect, documented by Kruger and Dunning in 1999, describes the asymmetry. People with limited knowledge in a domain tend to overestimate their competence, while experts tend to underestimate theirs. The more a person knows, the more clearly they see how much remains unknown. The horizon of ignorance expands faster than the horizon of knowledge. A high-intelligence brain sees the complexity, the number of variables in any situation, the number of layers in any question, and that awareness makes it more cautious in its judgments. It does not produce quick categorical answers because it knows reality is almost always more layered than any simple explanation can capture. This is not weakness, it is intellectual honesty. The fifth pattern is the one that often produces suffering. Overthinking. An analytical brain rarely turns off. The same cognitive processes that solve complex problems continue running in everyday life, analyzing conversations, modeling decisions, projecting consequences. A person with high intelligence can spend 30 minutes processing a sentence someone said in passing, not because they are easily offended, but because the brain automatically builds models. What was meant? What motives sit behind those words? What scenarios follow? Research by Penny, Midmer and Masmanian found that higher intelligence correlates with higher anxiety. The brain generates more possible outcomes, including negative ones. Where an average processing brain sees one situation, the high intelligence brain sees 20 scenarios. At least 5 of them are alarming. From the outside, this looks like indecisiveness or unnecessary complication. From the inside, it is a processor running multiple simulations concurrently. And learning to manage that capacity without being consumed by it is one of the central challenges these people face. The 6th pattern is one that research links to intelligence with surprising consistency: complex humour. From a neuroscience perspective, humour is an extraordinarily demanding cognitive operation. To understand a joke, let alone to construct one, the brain must simultaneously recognise a pattern, violate an expectation, and connect unrelated ideas into a surprising new structure. This requires participation from language centres, emotional processing regions, and the prefrontal cortex for logical bridging. Greengross and Miller, studying humour production and intelligence, found a stable correlation between higher IQ and the capacity for layered, ironic, often self-deprecating humour. People with high intelligence frequently use humour as a processing tool for difficult or painful material, a cognitive defence mechanism that creates analytical distance from distress. The 7th pattern involves timing. Many people with high intelligence report that their peak mental activity shifts to late evening or night. Some researchers connect this to evolutionary psychology. For millennia, early rhythms were dictated by the solar cycle, and individuals with higher cognitive flexibility adapted more easily to non-standard patterns. There is also a neurochemical explanation. In the evening, external stimulation drops, noise subsides, interaction ceases, the world decelerates. For a brain that has been processing input all day, this is finally the low-interference environment it needs for deep, undirected thinking, the kind from which breakthrough ideas emerge. Kanazawa and Perina documented this correlation between intelligence and evening chronotype. The trade-off is real. Chronic sleep deprivation degrades the same cognitive functions that the night thinking leverages. The pattern is a double-edged instrument. The 8th pattern is consistently misread in social settings. Observation over speech. In conversation, these people often do not rush to respond. Instead, they read social dynamics: who dominates, who is tense, who says one thing and signals another. They collect information, analyze emotional cues, and only then formulate a response. Their silence is not passivity. It is active processing, a chess player calculating the position before moving. When they finally speak, their words tend to be more precise and carry more weight than those of people who react instantly. In a culture that rewards speed and assertiveness, this habit is frequently misread as timidity. Behind the external calm, an intensely active internal analytic system is running. The 9th pattern separates genuinely intelligent people from those who are merely confident. Willingness to change a position when new data appears. People with high intelligence treat their beliefs not as components of identity, but as working mental models, hypotheses that can and should be updated. When new information arrives, the brain revises the model. This is not weakness of character or inconsistency, it is cognitive flexibility, one of the most reliable markers of advanced thinking. Most people cling to their beliefs because their ego has fused with their opinions. Changing a view feels like admitting failure, which the identity system perceives as a threat. A high-intelligence brain separates these processes. Its self-worth is attached to the search for accuracy, not to any specific position. Updating the model of reality is an achievement, not defeat. Underneath all 9 of these patterns sits a foundation: the persistent search for meaning. High intelligence is often accompanied by a heightened awareness of complexity, in society, in relationships, in human nature. This awareness leads to deeper reflection on purpose, identity, and how people construct meaning in their lives. Existential psychology shows that the need for meaning is one of the basic human drives. In people with high intelligence, this drive is amplified to an intensity that does not permit settling for simple answers. They cannot just live, they need to understand why they live. And this is simultaneously their greatest cognitive asset and the source of their deepest internal tension. The brain does not allow them to rest on easy explanations. And perhaps this is the most interesting thing about intelligence itself. It is not about solving equations or memorizing facts. At its core, Intelligence is a brain that does not stop exploring patterns, questioning assumptions, and trying to understand this strange, compelling puzzle called human nature.